Well, good morning, Science 10. Mr. Thompson here. I'm just going to continue along with 1.3 and finish this up. This is a little bit of extension material, and we're working with acceleration due to gravity. Now, it goes on here. Because of the force due to gravity, whenever an object is dropped, it will fall towards the ground. Due to the force of gravity, when objects fall, they will accelerate downwards at a rate of negative 9.81 meters per second squared. Now, we use the negative sign to indicate that the object will accelerate downward. And so the negative here is very important. It's a constant value that we're going to be using. And question number 1. The ball is thrown up into the air with an initial velocity of 15 meters per second. What is the velocity of the ball after 1.2 seconds? Now remember, with the basic acceleration formula, which looks like this, a couple of things to notice is that you can, of course, include vector signs for the vectors, which is final velocity, initial velocity, and acceleration. And you can also rearrange the equation. Now, yesterday I showed how to rearrange the equation for VF, so I'm going to start with the rearranged equation. VF equals VI plus A times T. I'm going to neglect to put the vector signs over there because really I'm just going to be putting in some numbers here, and the vectors will be indicated by positives and negatives. Start with 15 plus negative 9.81 times 1.2. Quick little calculation here. We get 3.228, and so when I look at my sig digs, I want two significant digits, 3.2 meters per second. So it was going up at 15 meters per second. After 1.2 seconds, it slowed down to 3.2 meters per second. It's not at its peak height yet, but that's where it's at. Let's take a look at part B. We're doing the same substitution here, except for we're just going to put in 3.5 instead of 1.2. So 15 plus negative 9.81 times 3.5. So I'm just going to bring back up what I had before and put in 3.5. Now here I have the following. Negative 19 meters per second. So it's already reached its peak height. It started coming back down and it's accelerating downwards. At this point, it must be below the point of release. And in part C, when is the ball at its maximum height? Well, here we're looking for time. So in the equation here, we're going to solve it for time. Time is going to be VF minus VI over A. Now when it reaches its maximum height, we set the final velocity to be 0. Now do you see the negative on the top and the negative on the bottom? They're going to cancel each other off. So I'm just going to take 15 divided by 9.81. So it reaches its maximum height at 1.5 seconds. Okay? Number 2, the stone is dropped from a bridge into a river below. What is the velocity of the stone at 2.4 seconds? Okay, same kind of thing. There's my equation. Now it's dropped, so I'm going to put in 0 for the initial velocity and negative 9.81 times 2.4. Negative 23.544, so now just careful with the rounding, so it'd be negative 24 meters per second. You can also think about this as 24 meters per second down, because of the idea that when we think about up, up is positive, down is negative. Okay? Thank you very much.